I'm going to talk to you about binary numbers. A binary number is essentially a number composed only by 0 or 1, only 2 digits. I show it in a moment. I take an input pin here and an X digit display here, and I connect the two in this way, and you notice here we have an error. The error is caused because here we need 4 bit in input, and this input pin is just 1 bit. So I have to change the data bits dimension here and choose 4. And now all it's okay. And let me show you how it works. I take the simulation mode, and here we have the number 0, written as 0000, 4 binary digits or bits. Bit is an acronym for binary digit. And this is not really interesting, but the next number, of course, is 1, and here is it. And then I have to write the number 2. I can't write really the number 2 because I have just 2 digits, 0 and 1, and so the number 2 is 10. And that's the strangest thing for people who are learning binary numbers. We are counting 0, 1, and then 1, 0. Let me show you how it works with an example with a normal decimal number. Here we have a counter, and whenever I click on this button, this number will increment going from 3, 4, 5, 6, and 7, 8, 9. So by now we have exhausted all the digits, because 9 is in decimal number, we have just 10 digits, 0 to 9. And what happens? When I click on the button, I see that the next digit to the left goes to 1, and the digit to the right goes to 0. And this happens again when I reach 19, 9, because we don't have any more digit here. And so on the next click, this goes to 0, and this one goes to 2, and this is 20. So something very similar is happening here, because we have 0 and then 1, and in this case I already I don't have any more digit, because we have just 2 digits in binary numbers, so I don't have a digit 2, and this case is quite similar here. When I reach the number 9, I don't have any more digit, and so I have to put a 1 here and 0 here. So in this case, I don't have any digit, and so I have to write 1, 0, which is not 10, of course, is 1, 0, and in binary numbers, 1, 0 is 2. So the next number is 1, 1, which is 3, and in this case, I don't have any more digits in this position and this position too. With digital numbers, this happens when I reach 99, and I don't have any more digits here. So when I reach 99, I have to switch this digit to 1 and this 2 to 0, 0. Here is quite similar. The difference is that here with binary numbers it happens a lot sooner, because it happens when I reach 3. I don't have any more digits here, so the next number would be 1, 0, 0, which is 4. and then 101. I don't have any more digit here, so the next number is 110, and then 111, and this case is similar to 999 in the decimal system, so I don't have any digit left here, so the next number would be 100, and then so on. I can, you see, when I reach 10 in a decimal number, this should be 10, the display shows I show you. This is 9. The next number should be 10, but here I have just one display, so I cannot display 10. And in electronic circuit, the number 10 is represented with the letter A, and the number 11 is the letter B, and then the number 12 is the C, and so on till 15, which is the number F. This particular kind of representation is called hexadecimal numbers. You don't have to worry too much about it now. By now, you can see that here we have a 4-bit binary number, and using 4-bit, I can represent all the number from 0 to 0000, 4 zeros, to 1111, which should be 15 in decimal numbers. And you don't need to worry too much about the details of the conversion between binary and decimal or hexadecimal numbers, or because there are plenty of sites or web pages and apps and so on that can calculate the conversion. For example, here I have the window calculators, and you can see I write a decimal number, for example 9, and here I have the conversion in binary. And for example, if I write 15, you can see the binary number which corresponds to 15 is 1111, and the letter is F. And so on. For example, if I want to write a number like 255, this should be 8 bits, all equal to 1. And in hexadecimal, don't worry too much, this number is FF. So, finally, in a binary number, we have a certain amount, a certain number of digits. The rightmost digit, this one, is called the least significant bit. Least significant because this is the least important bit in the number. And the first digit is called the most significant bit, because this bit is more heavy, more important, because, for example, 1 here is just a 1, but if I put a 1 here, this is the number 8. So, like in the decimal system, the digit which stands on the left is more heavy, more important than the digit that stands on the right. And with just 4 bits, we can represent just 16 numbers, because the first number is 0, of course, and the last number is 15, and this is a total of 16 different numbers from 0 to 15. So 4 bits is 16 number. And again, the reason is why here we have 4 bits, and 2 raised to the power of 4 makes 16. And for example, if I have 8 bits, in this case, I can write the number till to 255, or an amount of 256 different numbers from 0 to 255. And the reason is because 2 raised to the power of 8 makes 256. And so the total numbers is 256. From 0, you must remember we have also the 0, from 0 to 255. So, 5, sorry. So, if I know how many bits I have, I can tell how many numbers I can write using this amount of it. And this is exactly the same with the decimal numbers. For example, in this case, I have 3 digits, decimal digits, and the maximum number I can write here is 999, and I can write a total of 1,000 different numbers from 000 to 999. And why 1,000? Because in this case, we have 3 digits, and we have to calculate 10, which is the base of this system, 10 raised to the power of 3. So 10 raised to the power of 3 makes 1,000. So the binary system works exactly as the decimal system. The only difference is that in this case we have just 2 digits, 0 and 1, to represent all numbers.